Hello everyone, in this video I'm going to show you how to run statistical analysis using Rstudio. So in this specifically on simple linear regression. Okay, so simple linear regression is to see how one variable information can be used to predict another variable. Okay, so in this video I'm going to show you how the R script look like, what will be the output and how to interpret the output. So what do you need to have in order to run a simple linear regression? Firstly, you need to have your R or Rstudio open. Secondly is you need to import the data file into Rstudio. So this data file can be in Excel or CSV format, but preferably in CSV format. So what should be included in the data file or in the CSV file? It should mainly have two dependent variable information. Both has to be continuous type of variable. The dependent variable, the outcome variable, the one that you are trying to predict, has to be a continuous variable. The other variable, the independent variable that you are trying to use to predict the outcome, or the dependent variable, can be categorical or can be continuous, but the dependent variable has to be continuous. Now once you have the Rstudio open and you have imported the data file into your Rstudio to run the analysis, next is you need to select the package. Package is a documentation that comprises or lists all the functions that you would like to administer for a specific analysis. So it contains of the function, the way to write the analysis for every type of statistical analysis that you would like to administer. Okay, so in this case, analysis, I'm going to use a psych and also stats package. And then the fourth step is, of course, to write the script in the Rstudio. So you need to tell Rstudio what is the step-by-step work process that it has to run in order to get to the linear regression. Firstly, you have to set working directory. So what is setting working directory? You have to inform the Rstudio where is your data file is located. Okay, and then if you have your R script prepared earlier, you need to also save it at the same place, because every time you set your working directory, that is where all the information will be stored, and if you would like to retrieve it, that's where that you have to go and check it out. It's like setting a path, or setting a folder. Next is you have to load the library. Load meaning you're activating the libraries. So in this case, you have to activate the psych and stats package or stats library. That is import the data file into Rstudio. Okay, so you're calling in the data file. And then fourth one is you need to test the assumptions. So here you have to test two assumptions for linear regression, whether your data is appropriate or not to run a simple linear regression. So what are the assumptions? Firstly, you need to test for normality. Is your outcome variable normally distributed? Okay, so that is the reason why we say the outcome variable, the dependent variable, okay, the variable that we would like to make a prediction on. Is it normally distributed? Second is test of independence. So we want to make sure that the variable that we collected, the information of variable, the two variables that we collected, are independent to each other, meaning that when a person is responding to the questions or giving answers, they are not being influenced by another team member in the group. Okay, so there is no statistical test to test directly or assess directly the test of independence, but we can assume that during the data collection, that individuals did not communicate and did not interact or did not influence one another's responses. Okay, and finally is to run the analysis. So how does this simple linear regression script looks like? Okay, so as we said, the first step is to set the working directory. So we have to specify the location of the folder. So in my case, I have set it at the G drive and under the folder called demo. But when you are doing it, you have to change it. So basically, always create a folder in your desktop or in your documents or even in your pen drive, and then label it properly and then set it as your working directory. Second is you have to load the library, meaning you have to activate the packages that you would like to use. So in this case, I'm using stats and psych. And for the third one is I have to import my data. So I'm bringing in my data for analysis. So in the demo folder, I have saved my data file as finaldata.csv. Okay, so it is in a CSV format called final data. But once it's being imported into RStudio, it will be called as data. So this data on the line 9, okay, on the line 9 where it calls data, you can actually change it to a different name. Okay, so it is anything that you label it before the arrow. Okay, before the arrow is considered you are just giving, you can give any name. So anything after the arrow, it is actually the function, the instructions that you would like to give to the RStudio. So this instruction has to be specific. You cannot write your own functions. You can, but if you are using the package, you have to follow the packages one. Okay, so you have to follow the packages way of writing. So you have to follow stats and the psych package. So next step is you have to test for assumptions. So you have to test for the normality of the variable. So if you have 2 or 3 continuous variable, you run the normality check for all the continuous variable. Okay, so in this case, I have 2 variables. Both are continuous: work experience and job satisfaction. So my ultimate goal is I would like to predict someone's job satisfaction based on the years of working experiences. So I would like to see if I know the work experience of a person, can I predict the level of their satisfaction towards the job. So in this case, I'm using the work experiences to predict about job satisfaction. So for example, if the person is just joining in, okay, and then I don't have to wait for 5 years to know what the job satisfaction is. So I can use this equation, the prediction equation, or the simple linear regression that I'm trying to find to use to predict what will be like, or how much will he be satisfied when he reaches 10 years of experience. So I can use it. I don't have to wait till the time of the event, but I can use the current information to predict what is going to happen. So, and then next is test of independence. Okay, so test of independence, we assume that there is independence in the observations that we get, or the responses of the information that we get about work experience and job satisfaction. So people do not influence one another. And finally is to run the analysis. So what we are doing is we are putting fit, we are trying to fit. Okay, so we are this fit, you can change it to a linear regression or regression, so you can name it whatever you want. And the LM means, okay, so LM is actually trying to say that linear model. Okay, so simple linear regression, so linear model. Okay, so please model job satisfaction, okay, being predicted by work experience. Okay, so this is the dependent variable, job satisfaction, and work experience is the independent variable. So the independent variable we manipulate, so the number of years working experience will differ. So from 5 years, 2 years, 3 years. So we use that years to predict what is going to be the satisfaction like. Okay, and then the data. So where do they get the information from? So the file called data. Okay, and then we write the summary, the fit information. This summary will provide us the results of whether work experience even is significant to predict job satisfaction or not. So firstly, we have to see if this work experience is even relevant or related to job satisfaction. Is it a significant predictor? Okay, is it a significant independent variable? So predictor, remember we are using work experience to predict job satisfaction. So the predictor variable here is work experience. So we want to see if even this work experience is a good predictor or not. Before you can make a prediction, we want to see this variable can be used to make predictions. So that is what I mean by whether it's a good predictor or not. So we have to check that. So what does that results look like? So for the first one, setting the working directory, load the library. Okay, so all this will appear under the command type, under the history tab as well as the environment tab. So basically it's just running it. It's just like uploading it and setting it. So it doesn't actually come out in your console. Next is you need to test for the normality. So in this case there are two continuous variables, both the predictor and the outcome variable, both are continuous variables. So we would like to see whether they are normally distributed or not. Okay, so how do you check for normality? So the describe here is you are describing the work experience variable that is stored in data. Okay, so what do we look for? We look for the skewness. So the skewness value should be within -2 and +2. If it is within the range, then the normality is met. So in this case, my skewness is -0.2 for work experience, and for job satisfaction is 0. So basically they are within the range and they are normally distributed. Now looking at the analysis. So what we did here is we would like to see work experience predicts job satisfaction. So where do we supposed to go first? Firstly, you need to check the coefficients. Okay, so coefficients is the contribution or the correlation coefficient, like how much information does this variable, this predictor variable is contributing or influencing the outcome variable, the job satisfaction. So you look at the coefficients first. Okay, so intercept and work experience. So look at the work experience probability value. So is it less than 0.05? Okay, so what does that actually mean? Okay, so we test the work experience. Okay, we got a t-value of 2.684. Okay, so what is the probability value associated with this t? Is 0.00834. If you calculate manually, what you do is you calculate the t critical. So this t value is compared to the t critical to see if work experience is a significant predictor or not. So in this case, you do not have to make the effort to find what is the t critical. So what they do is they have already given us the probability value associated with the t statistics. So for 2.684, the area under the curve or the probability is 0.0834. Okay, so what is the probability or the cutoff value that we set to say or to find the t critical? Remember the level of significance that we predetermine. What is it? It is the alpha value. The probability value is just 0.05. So that 0.05, the area or the proportion of 0.05, we find the t critical and we compare to the t statistic, the computed t statistic. But in this case, you do not have to do that because they have already converted or find the probability value for the t statistics. Okay, so what we need to do is we take that probability and compare to our T critical probability, which is 0.05. We have already predetermined it. So from here we compare whether our work experience variable is less than or greater than the cutoff of the significance value, which is 0.05. So is it greater or less? So in this case it's less than 0.05, meaning work experience is a significant predictor to job satisfaction. Okay, so meaning you can use somebody's work experience to predict job satisfaction. Okay, so what is the next thing? So next thing is, how do we explain it? Okay, so work experience is found to be a significant predictor to job satisfaction. So every 1 unit increase in the years of experience, so every time 1 unit increase in the year of experience, the satisfaction multiplies or increases by 0.75 unit. Okay, because this is positive. So when your work experience increase, your job satisfaction also increases by how much? By 0.75 units. Okay, so there is a relationship. Yes, you can predict job satisfaction using work experiences. Okay, so every time a person's work experience increase by 1 unit, their job satisfaction will increase by 0.75 unit. Okay, so that is the most important information that you need to extract from the result. So what does that mean? Okay, so remember we are using the two information to find the prediction equation or prediction line. Remember, simple linear regression line. Okay, so how do you actually find the line? We try to fit the y equals to mx plus c. So we are trying to fit a straight line. So we are trying to fit whether we can, because we would like to predict one information to another. So we would like to see whether they form a line. So all those data points, can it be fitted into a line? Okay. So in this case, y equals to mx plus c. So y is the outcome variable. What is it that we are trying to predict here? Job satisfaction. And x is the work experience. So work experience will be used to predict job satisfaction. And then plus c is the intercept. So the intercept meaning that when your work experience is 0. So intercept meaning when the value crosses the y-axis. Okay, so when it crosses y-axis, meaning the x is equals to 0. Okay, so x is equals to 0, meaning 0 multiplied by m becomes 0. So when c is when x is 0. Okay, so when it crosses the line for the y-axis, the outcome axis. Okay, so in this case it is 48.07. Okay, so we can use this equation to predict a person's job satisfaction given the information about their working experiences. Okay, so what based on this equation, so what will be the job satisfaction for a person who has no working experience? No working experience. So what will be the job satisfaction? So no experience meaning 0. Correct? So work experience, no experience meaning 0. So 0.75 multiplied by 0 and then you plus 48.07. What will be your results? It will be 48.07. So when there is no working experience, a person's job satisfaction will be 48.07. So when you add working experiences 1 unit, it will increase by 0.75 and then it will keep on adding. So for example, if your working experience is 5 years, okay, so what will be your job satisfaction? So what you do is you substitute 5 in the x, in the working experience. So 0.75 multiply by 5, you get 3.75 plus 48.07. So your working job satisfaction becomes 51.82. So as we said before earlier, every time that work experience increases, job satisfaction will increase. Okay, so that is actually how you can make predictions about a person's job satisfaction using the work experiences. But as you say, this is a very simple linear regression. Actually, when you want to talk about in reality, when you want to talk about job satisfaction, there is not only one variable, not work experience alone can actually explain job satisfaction. There might be other reasons. There might be age, there might be a relationship, there might be a salary. Okay, so there is a lot of other predictors that can help to explain job satisfaction. Okay, so work experience is not the ultimate one. Okay, so in reality you will have more than one predictors to use to explain job satisfaction. So I hope it was clear. Thank you.